Hello viewers, welcome to the first lecture of operating system. In this session we will understand the operating system and what operating system can do, how it works, what is the basic structure of the operating system, what are all the functions we have in the operating systems. Now let us start with the definition. Operating system is a software that manages the computer hardware. It also provides a basis for application programs and act as an intermediary between the computer user and computer hardware. Means the operating system is a software and this software manages all the computer hardwares, peripherals, right, and also it provides the interface between the user and the computer. If user wants to access any of the computer hardware with the help of operating system only, the user can access the computer hardwares. So this OS is acts like an intermediary software or intermediator between the user and the computer hardware, so that user can interact with the hardwares of computer. So it also provides the basis for application program. So what is the meaning of this basis for application program? All the application softwares are loaded over the operating systems. We will understand that in next slide. We have mentioned some of the examples of operating system like Linux, iOS, Unix, Mac, Android, Windows. So these are some of the examples of operating systems. Now in this figure we will understand how this operating system works, right, and what actually this OS do, right. So we know that a computer system it can be divided roughly into 4 components, as you can see on your slide. A hardware, this is the bottom hardware, computer hardware. So this is the first component. Second is the operating system. Third is the application programs, or we can say that these compilers, assembler, text editor, database, all these are the application program. All these application programs are installed over operating system. And the fourth one is the users. So these are the 4 system component. We can say computer system are roughly divided into 4 components like hardware, operating system, application program, and the user. As far as the hardware is concerned, hardware is nothing but a CPU, memory, input output devices, right. So these all devices, hardware provides the basic computation resources for the system. User can interact with the computer with the help of these hardware. So these are CPU, memory, IO devices. This compiler, assembler, text editor, and the database, all these are called as application programs, and these application programs provides the interface between the user and the computer, because user interact with these application programs, and user can solve any computational problem with the help of these application program. And these application programs installed our operating system. Hence these application program interact with operating system, and operating system provides the interface of the computer hardware, so that the user can access these computer hardware. In this fashion, a user can access all the computer hardware with the help of operating system, but user is interacting with the database, text editor, word processor, spreadsheet, assembler, compiler, web browser, etc. And the operating system which controls and coordinates the use of hardware among the various application program for the various user. So this is how we can interact with all the computer hardware. So operating system which provides the mean for proper use of these resources in operation of the computer system. And this OS is similar to the government, as government provides all the facility to its citizens. Similarly, operating system provides all the facility to its users, right? We know that the government which performs various functions for their public. Similarly, this operating system provides the proper environment where the user can interact with all the computer hardware. So this is how this structure can be used to interact all the users with the computer hardware. Okay, so first of all, the user is interacting with the compiler, which is called as application software, and operating system, then computer hardware. Next, coming to the types of operating systems. So we have batch operating system, we have time sharing operating system, distributed operating system, network operating system, real time operating system, multi-programming, multi-processing, and multitasking operating system. So these all are the types of operating system. One more type is included, that is mobile operating system. Nowadays everyone is using the smartphone, tablets, etc. So the operating system which installed on smartphones, tablets, etc. are called as mobile operating system. Now you can see all these 8 types of operating systems we will understand in simple words with examples. What are all these operating system, how this operating system works, what is the work of each type of operating system. So we will understand one by one. Let us start with the batch operating system. So batch means all the jobs are gathered and at a time submitted to the CPU. That is the work of the batch operating system. If assume that one process enters the operating system, it doesn't occupy the CPU directly and doesn't execute. So all the jobs are gathered and created as one batch, and operating system is responsible for acquiring or gathering all the jobs and making its one batch and submitting that batch, means n number of jobs at a time, to the CPU. So this is how this batch operating system works, right? So it is commonly used in environment where large number of repetitive tasks need to be executed efficiently, right? The second is the time sharing operating system, which is also known as multitasking operating system. Time sharing means among n number of users, the CPU time is divided into the time quantums, because CPU is very fast device in the computer system, so that we can execute any process in the CPU in millisecond. So time sharing operating system which allows the multiple users to share a single computers simultaneously, means in multitasking every user thinks that the system is dedicated to them only. By this example we will understand. Assume that there is user 1 and user 2, they are constantly accessing the computer. The CPU is allocated to user 1 also, 2, 3, 4, 5, 6. So there are 6 users, and this CPU is allocated to each of the user, and while assigning the CPU a particular time quantum, one time quantum is allocated to user 1, user 2, user 3, user 4, right? So time quantum means the particular CPU time which is divided into a small pieces, and that small piece is called as time quantum. So in CPU scheduling also we will understand in depth regarding the time sharing operating system and time quantum and all. So simply you just understand in this time sharing operating system, when a multiple users are accessing the same CPU, the concurrently all the tasks are performed by the CPU with the help of these time quantums. Each time quantum is allocated to each of the user. User thinks that a system is dedicated to their work only. User 1 thinks the entire system is allocated to me. User 4 thinks the entire system is allocated to me only. User 3 also thinks the same. Fifth also thinks the same. Sixth also thinks the same. But actually the CPU time is divided among the multiple users, and every user is interacting and performing their task concurrently in the time sharing operating system. Therefore we are saying multitasking. Multi means more than one task. More than one task means all the 6 users can perform the different task. The 6 tasks at a time they can perform. They are thinking that they are performing their task. The entire system is allocated to them, but the actual thing is it provides the time quantum in milliseconds, so that it changes very rapidly. So everybody thinks that the system is working for them, but the system is working for all. So hence all the user can interact and they can perform their tasks concurrently in the time sharing operating system, so that they can perform their individual task. Hence all the 6 users are performing 6 different tasks. So that's what it is called as multitasking operating system. Third is the distributed operating system. So in the distributed operating system, you can see in the figure, all the workstations are there, personal computers are there, file server, login, print, other services, all they are connected with each other via the LAN, local area network. One of the system who connects all these computers together, right? So therefore these operating systems are designed in such a way that it can run a multiple interconnected computer, and they are seems like working together as a single computer, but they are working individually, but overall they are working for a single task, for a single working like a single system. So in this, all the resources are shared among all the devices connected to the LAN, and all the services are provided transparently, and all the users can be viewed transparently. So all the users can allowed to access the resources from the connected machine. The fourth is the network operating system. Again, in this network operating system, as the name suggests, network operating system means all the computers or clients are get connected via the network, and these operating system, network OS and OS, manages, coordinates the network resources, allowing multiple computers to communicate and share the data within a network. And also it provides the essential services like file sharing, printer sharing, network security to all the clients which get connected to this network operating system. The fifth is the real time operating system. RTOS are very crucial for where the applications such as robotic applications, aviation applications, or industrial control systems were used. There it is used. Some of the characteristics also mentioned in this slide for RTOS, like consistency, scalability, performance, prediction, reliability, etc. The sixth is the multi-programming operating system. The second we were discussed multitasking operating system. In the multitasking and multi-programming, there is one difference in programming and multitasking. Multi-programming means we can keep the CPU busy all the time to maximize the throughput, to maximize the utilization of the CPU. But this multi-programming doesn't allow all the users to access at a time. So therefore what we are saying, in multi-programming operating system, this system allows the multiple programs to reside in the main memory simultaneously. It efficiently switches the CPU attention between different program and maximizing the process utilization. Means if multiple processes are entering into CPU, say P1, P2, P3, right, are entering into CPU, it will enter simultaneously one after the other, right, one after the other, or it might be given some priority. Based on that priority, P1, P2, P3 will occupy the space in the CPU and all the processes gets executed. But before that, all these three processes will enter into the main memory, right, and thereafter these processes occupy the CPU attention and executes these processes in the CPU. So therefore we say that to efficiently achieve a simultaneously running system, each program is allocated CPU time. So each process will occupy or allotted a CPU time in time sliced manner, typically using scheduling algorithms such as round robin scheduling. So what is mean by time slicing? A particular 4 millisecond time of the CPU is allocated to P1, a second time slice of 4 millisecond is allocated to P2, the third 4 millisecond time of the CPU is allocated to P3, and similarly the fourth time slice again allocated to P1. If the P1 doesn't complete in 4 millisecond, then another 4 millisecond is allocated. In this fashion of allocating the CPU to the processes is called as round robin scheduling. We will understand this concept in our upcoming videos. The seventh is multiprocessing operating system. In the multiprocessing operating system, this operating system utilizes the multiple processors or core within a single computer to execute the task. It improves the system performance and enables the concurrent execution of the various processes. So example is the Linux and Windows. In certain editions of the Windows, we can find this multiprocessing operating system. So multiprocessing means you can find this figure where you can find there is a processor 1, processor 2, processor 3 dash dash processor n. So every processor is having the register cache. They use a common bus among all the processors. Memory can be used by all the three processors. IO devices can be used by all the three devices. So multiple processors or core within a single computer to execute the task. Assume that there are 2 tasks or 3 tasks entering the CPU. If the core is dual means one, physically there is a one CPU, but logically there are 2 CPUs, right? I will tell you what is physical, what is logical in upcoming videos. Now let's understand. Assume that there is only one physical CPU, but logically there are 2 CPUs. What happens when the 2 process say P1 and P2 enters the operating system? Physically there is one processor means we think that only one process gets executed, but in multi-processing what happens, logically there are two processors, CPUs means the two processors can be executed at a time, right? So concurrently executed by CPU 1 and CPU 2, P1 and P2 processors. So in this fashion we can execute multiple processes at a time in a single computer. In a single computer we might be having two physical CPUs also, or multi processing. Multi means more than 1, 2, 3, 4 processors in a single computer that can handle multiple tasks. Okay, the eighth one, the final type, means the eighth type of operating system is the mobile operating system. So this mobile operating system gives the power to the smartphones, because nowadays everybody is having the smartphones and everybody is using Android operating system in our smartphones, either it is Android or iOS. So mobile operating system is Android or iOS, or in some mobiles there is a Windows operating system is also there. So we are using like smartphones, tablets and other mobile devices, and in those devices we are using this mobile operating system, and these are the user friendly interface, because these operating system provides user friendly interface, supports the mobile hardware components, allow to access the various applications installed on our tablets, smartphones, and this operating system includes iOS, Android, Windows, etc. And this mobile operating systems are designed to support the touch based interaction, because most of the tablets, smartphones are touch based nowadays. So it provides such a design through which the user can interact all its applications with the help of touch screen, and provides the user friendly interface with the icon, menus, gestures to navigate the device. Alright, so these are the types of operating system. After types of operating system, let's understand the function of operating system. The first is it provides the interface between user and hardware. The first and foremost function is to provide the interface between the user and hardware. A user can interact with the computer when operating system provides all the functionalities to the user. If it doesn't provide this function, the user cannot communicate with the computer hardware. So therefore the first function of the operating system is it provides the interface between user and hardware. The second is the allocation of resources. Allocation of resources means the needed resources by the users are allocated by the operating system. Similarly, memory is managed by the operating system. Security and etc. can also be managed by the operating system. So these are the functions of the operating system. Whenever user wants to interact with the computer hardware, they must interface with the operating system. So user interact with the applications are loaded over the operating system, and operating system interact with the computer hardware, and all the required resources is allocated by the operating system. It's a responsibility of the operating system to allocate the requested resources to the user, and also memory management, managing the memory, allocating the CPU and providing the security, etc. is the responsibility of the operating system. So these all are the functions of the operating system. Apart from these functions of the operating system, we have goals of the operating systems. So coming to the goals, the operating should be convenience, it should be effective, the efficiency should be there, or we should have both of these in operating system. right? So goals of operating system is it should be convenience, it should be efficiency. So this is the basic structure what we have seen at the beginning of the lecture. So thank you for watching. Like, share and subscribe.